In the first lecture, we looked at tool validation in general. We looked at data carving and some of the principles behind that. And we looked at the scientific working group on digital evidence, tool testing and validation procedures, and their report template. What we're going to do in this lecture is look at the setup of how we would go about creating some media with known characteristics to determine whether we can validate a particular tool. So the tools that we'll be using for this example, of one of which is called PhotoRec. And the two that we're using, I've used both of these with some amount of success, but I'm going to let you be the judge of the validity of these tools for a particular task. So this is the TestDisk and PhotoRec website. It comes as a set of tools that can be used for data recovery. Notice that they have them available for Windows, 32 and 64-bit, for different Linux kernel versions, and even for the Mac OS. The other tool we'll be using is called Scalpel. And this is a file carver. And you notice here where you can download the file, and it's available for Linux, Windows, and Mac OS X. And so it will be up to you to go out and to read about these two tools and to use these for a data carving exercise in order to validate these tools for that specific purpose. So I've downloaded the files, and I did so in Linux because I'm assuming that you'll be using Linux for this assignment, but you don't have to. You could use Windows. In fact, that'd be really cool if you did some validation using the Windows version or the Mac OS. If you've got Mac OS, I really don't care, because it would be a really good contrasting assignment showing between students not only how well the tool works within an operating system, but also across operating systems. So choose one of those. Choose Windows, choose Linux or Mac OS X, and go ahead and download the appropriate version for that. And now what we're going to do is we're going to create the media that is required for this tool validation exercise. So what do we need to do? Well, what we're going to do is we're going to be, as I said previously, doing a data carving assignment. So we're going to be recovering some files just based, let's say, on the header and footer information. So what do we need? First is we need some kind of media, and the second thing we need are the actual test files. So let's decide on what type of files we want to recover. Let's see if we can recover some Office files. They have known headers and footers. Let's recover JPEG files, and let's recover some PDF files. How about that? So we'll do 3. So the first thing we need to do, okay, and this is going to look a little different than it did before because I just realized that I don't have OpenOffice on here, which can be used to create Word files. So I had to restart in Mint 13. So I said we wanted to recover, did I say Word files, which would be Office and a PDF and JPEG. And so if we really wanted to do this correctly, and this might be what I do for the assignment, is that I will give you those files. I will give you the files I want you to data carve, and so they'll be consistent across students. And I think that'll make a lot more sense. So let's just select one of those. Let's just select, we've been working on JPEG files, so that's what we'll do. So pause this for a second, and I will download a JPEG file. In fact, I'll copy several different files onto the media that we'll be working with. But in this case, if we had hundreds of these files or thousands, which I've actually had to recover, we don't want to do that manually. We want to automate the process. Okay, so I put everything in a single directory. I went in and I took a known JPEG file and I created a doc file in Microsoft Word for the Mac and a PDF file. It's the same document, I just saved it as a PDF. And remember, we're using headers and footers to identify files, so what we might want to do is run the file command on these files to make sure that they're reading the header properly. According to this, hello world.doc is a composite document file, gives a lot of information about the MAC times and the type of template used, who the author is. Hello world.pdf indicates it's just a PDF document, so obviously the doc file has a lot more metadata associated with it, but does correctly identify it, including the operating system. And the JPEG file is a JPEG image. So according to that information, we know that the headers were written out appropriately. And now what we might want to do is what we want to do is create hashes of these files, correct? And we want to output those to a file name validation.sha1, so that when we recover these files, it will know that they were recovered appropriately. So if they're using the headers and the footers, then these files should be recovered correctly, and you should have the same exact SHA-1 sum for each file. Okay, we're still working on creating our test media, so what we want to do is to go ahead and use DD just to create and this is something that you should have seen in some of the previous videos, or rather we'll use DD to create a blank image. And first thing we need to do is just to write zeros on it. The output file, we'll call that assignment 3.dd. The block size equals 1024, and those are very small files. And so we can do a count of 1,000, and that should work. So it's 1 megabyte. So that's something small. Now let's look at the man page for MKFS and search for, well, this is going to be FAT12. It's going to be FAT12 because it's so small. And so we can go ahead and use sudo mkfs dot, we can use vfat or MS-DOS. In this, it's really not going, it shouldn't matter. In fact, it might be something you want to test out, but we're going to use vfat for this and assignment 3.dd, and we'll run file on that, see what it says. And it looks like it's a FAT12, and it did that appropriately. So we have an image that's formatted FAT12. We don't have anything on it. We need to copy those files on there. And what's our next step? Our next step is we need to mount that, correct? Because we need to copy the files on there. So we'll just make a directory, and then we'll mount, and the option is loop. Because it's an image file, it's not a physical device. And it's assignment 3.dd on my mount. We'll type mount to see that it's mounted down here at the bottom. Mounted is type vfat. Let's clear that. And now let's copy. And since you need to use sudo for that because it was created as root and it was mounted as root, We're going to copy James on there, and then hello dot whatever into my mount. Did it copy them? Yes, it did. Why don't we go in and run SHA-1 sum on those just to make sure it didn't change. It shouldn't. Okay, B924, those are the same SHA-1 sums, so it copied it correctly. It didn't change by copying them. And so now you can unmount that. Make sure it's not mounted. And there's our DD file with those 3 files on it. So we need to do one more thing. And what is that? We need to do one more thing to make our test media complete. Well, we're assuming we're having to recover files by their headers and footers, that is, we're data carving, because something has corrupted the disk. Or for some reason, we've accidentally deleted files and we can't use the FAT information or the master file table or similar information structures in order to recover the corrupted or deleted information. So what we need to do is now that we've copied those files to disk, we need to delete them. So we need to go back and mount and delete the information. So we need to go back up and select that mount command. Make sure that it's mounted. Okay, it is mounted. Let's go in, and there are the files. And now let's delete them. rm-rf. Oops, sudo. Okay, there's nothing in there, right? Okay, let's get out of the mymount directory and let's sudo umount mymount. And it's unmounted. Let's go in and take a look at that. Sudo assignment3.dd. Look at that with the hex editor. And let's scroll down. Notice, let's go back up. Notice, let's go to offset 200, which in hex is 512, the first sector. Notice the 55AA is the end of the master boot record. The F8 indicates the hard drive, which is really not, but that's the descriptor that's used. And there's nothing in the FAT. There's nothing in the FAT, which means that there should be no files in allocated space. Let's go to the second one, the FAT at 600. Notice no entries in that FAT. Go to the root directory. And there's the long file name. There's the short file name for James JPEG, E5. E5 for hello.doc. And hello world PDF E5. Are those files still on here? Let's take a look. Okay, so at offset 5200 we find there's a JPEG file, FFD8 FFE0 is the header for JPEG file. Let's see if we can scroll down to see our next file. And look, there's some content right there. So that was either the Word file or the PDF file. Okay, at offset FA00, the D0CF11E0A1B1 is the header for Office. There's our Office file. And at 15200, there's the header for a PDF file. So those files are still there, right? The files are still there. In fact, so we know that they're there. And so now we can unmount that. Oh, we've already unmounted that, right? Yeah, we're okay. So now we've got our the media for the tool validation all set. Let's go into test disk and see what that's requiring. And let's look at the README file. Okay, notice some of the things that it's saying in here, what types of files it can search for. So these are claims it's making. What do we have? We've got JPEG, HTML. We've got Microsoft Office document files. Does it say PDF? And it's got PDF. Good. Okay. Does it have zip files? I might add that on to TIFF. Oh, there it is at the end. Zip. Okay. And what does it run under? DOS, Win9X, Windows, Linux. And there we go. Okay. Okay, so I'm not going to run those. That's going to be your assignment, because what you're going to do is you're going to take the files that I upload. You're going to follow the procedure using DD to create a blank test image. You're going to copy those over. You're going to run SHA-1SUM to get those hash values, and then you're going to use each tool to recover those files. And then you're going to compare the recovered files, the hashes of those files, to the hashes that you previously calculated to determine whether the tool worked appropriately. And you're going to write all that up in the SWGDE template format. This is very straightforward. It's not that hard. It takes a little time. If you make a mistake, start all over again. It doesn't really matter, but I want a really good job on the assignment. Make sure that your testing is complete. Make sure you have all the information there. And if your test fails, that's fine. If your test works, that's good as well. But the whole idea behind this is that we're scientifically testing whether these tools do what they claim to do.